Hello everyone, I'm Suhasini. Welcome back to my channel Learn with Suhasini Shinde. In the very last class we have discussed about the capacitor, what was the principle of the capacitor and how do we calculate the capacitance of the spherical sphere, right? And in this class we study about the combination or how the capacitors are arranged, right? We have two main combinations of the capacitor, right? One is when capacitor connected in series and another is capacitors connected in parallel. Let us understand in this particular class, when capacitor are connected in series, what will be their behavior and how the capacitance is affected, and when they are connected in parallel, what is the behavior there and what all the parameters that are changed or affected, right? Now let us understand one by one. In the very first section, first we will deal with the series arrangement of the capacitor. Say for example, the capacitor are arranged in series, right, such that every capacitor has its own capacity of holding the energy. Say for example, the capacitor 1 has its capacitance as C1, this is C2 and this is C3. Right now this is connected to a potential, all the capacitors that are connected in series, and in turn they all are connected to this potential V, right? And now the positive plate, the positive of this particular potential is connected to the left of this first plate, right? And hence this plate gets a positive charge of Q, right? It is positive. Only the positive charges are given to the left side of the C1 plate, right? And due to the process of induction, what happens? This plate, the second plate left side, will be charged with negative. Why? Because all the positive charges attract the negative charges in this plate. These are two individual separate plates, right? Now the another right side of the plate will be charged positively. Right now this positive and positive starts repelling each other due to the like charges, and this positive will repel such that it come and accommodate on the left part of the second plate. Right now again induction process happen. The charges that are present here the negative charges that are present in this second plate will be attracted and you get negative charges here, right? And the positive charges are again segregated on the right hand side. Now this positive charges are further repelled such that it come and accommodate on the third plate, right? And due to again the process of induction, you get all the negative charges here, right? And all the positive charges are accommodated on this, right? Now do you understand the logic of connecting it in series? All the positive charges are attracted by this negative terminal, and hence this plate behaves negatively, right? Now this is the combination of the capacitor in the series. Right now what exactly Q charge that is being applied here, the same amount of the induction or the negative charges are created on the second plate, that we call it as minus Q, right? The amount of the charges segregated or acquired on this plate will be exactly equal to the amount of the negative charges on this plate. It again carries the same thing for the rest of the two plates, that is positive Q, the same amount of the negative Q here, positive Q, and the same amount of the induced negative Q here. What does this arrangement mean now? The charges remain same throughout the plate, right? And hence Q is same in all the capacitor. Though the charges are same accommodated in all the capacitor, the capacitance is different. They have C1, C2 and C3 capacitance, right? And due to the different capacitance, they generate different voltage level, that is potential level. Potential of C1, say it be V1, potential of C2 is V2, and potential of C3 is V3. Though the charges accommodated in all the capacitors are same, still the capacity is different. Why? Because they have different capacitance, right? Now what you do is, if at all this particular arrangement has to be equivalently represented, then how do you represent? The equivalent diagram or the effective capacitance, if you want to denote, then it can be written like this: positive, negative. This is positive plate, this is negative plate, this is positive, this is negative, this is C, that you can take as equivalent capacitance CS. S is series, it is connected in series, and this is potential difference, right? Now what is this equivalent capacitor? This equivalent capacitor generates exactly the same amount of the capacitance that is generated by the combination of three capacitors, right? Instead of connecting three different capacitors clubbed together in series, we give a equivalent capacitor, right, which exactly behave and has same parameters and value as that of the series connected capacitor, right? Now what you do, now if at all you want to find out what is the potential of this equivalent capacitor, how do you do it? V is equal to Q by, right, CS. What is C? We have this formula: voltage, that is potential, will be equal to Q divided by C, right? This C is the effective capacitor that is connected. Now this equation is for this, right? This is the effective or the equivalent capacitor, or the equivalent diagram, right? Now if at all you want to find out a potential of this particular circuit, then what do? First you take the individual potential because of C1, individual potential because of C2, and individual potential because of C3, you add together, then you get a equivalent potential, right? So how do you write? What is V1? If at all you want to write what is if at all you want to calculate what is the potential only because of this, then it is Q divided by C1, right? In the similar ways, if for the second one, then it is V2 is equal to Q divided by C2, and V3 is equal to Q divided by C3. If you can remember now, if you can clearly notice, I have not written Q1, Q2 and Q3. Why? Because the charges are same, right? The charges that is accommodated or stored on the capacitor plates remains equal throughout the series, right? And hence there is no need, or there is no point in denoting it as 1, 2 and 3. If the parameter or the value keeps on changing, then you denote that C1 is different than C2, C2 is different than C3, right? And hence the charges remain same and equal, so we just write Q everywhere, right? The potential across the capacitor C1 will be V1 Q by C1, and so on. If at all you want to find out what is the total potential of this particular circuit, then what you do, you just take or a vector, or you just add all the potential V1 plus V2 plus V3, right? Now substitute, you have, now this is the equivalent potential, and these are the potential of the circuit elements. So how do you do? Right now you just substitute all the values. How do you do? Q divided by CS is equal to Q by C1 plus Q by C2 plus Q by C3, right? Q get cancelled, and you are left out with 1 by CS is equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is the total capacitance produced by this particular circuit, right? The equivalent capacitance is given by this formula, right? Now what is the ultimate logic of the capacitors connecting in series? In this combination, whenever you should remember a very important note, and this can be asked in your JEE and the NEET examination, what is the total effective capacitance when the capacitance are connected in series? The capacitance, the equivalent capacitance will be always less than the smallest capacitor value. What does this mean? Say for example, these capacitors, say for example you have three capacitors, right? C1 and C2 and C3. This is of 1 microfarad, right? 2 microfarad and 3 microfarad, right? Now this is connected. Now if at all you want to find out what is the total or the effective capacitance of this circuit, then what you do, you have this formula, you use 1 by C1 plus 1 by C2 plus 1 by C3, right? You put all the values, what is 1 by 1, 1 by 2, 1 by 3, it is 6, it is 6 plus 2 plus 3. It is 11 by 6, that is 1 by CS. If you wanted only this capacitance, then CS is equal to 6 by 11. What is 6 by 11? It is 0.5454 something. microfarad, right? Now you get the total capacitance less than the value of the smallest capacitor value, right? What is the smallest value of the capacitor in this circuit? It is 1, right? 1 is less than 2 microfarad and 3 microfarad. And when you are connecting the capacitors in the series, right, the total capacitance what you get here, now I am talking about this capacitance, the total or the effective capacitance what you get out of the circuit will be lesser than the amount, lesser than the value of the smallest capacitor. The smallest capacitor is 1 microfarad. Then what is the CS, that is the effective capacitance you are getting? It is 0.5454, which is lesser than 1 value, right? And hence whenever you want to decrease the capacitance value, you take the combination or you select the combination in series, right? Whenever you wanted to reduce down the level of the capacitance of the circuit, then you always use this particular combination, that is series combination of the capacitor, right? Okay, now let us understand this combination when the capacitors are connected parallelly. Say for example, there are 3 capacitors whose capacitance is C1, C2 and C3, right? Now this is the positive terminal. This positive terminal generally connected to all the negative, or this positive terminal is connected to all the left side of the plates, and hence this positive charge will be provided to all the left hand side of the section, right? This positive Q is divided on all the left hand side plates, and all the left hand side plate will be charged positively, right? And this side, right hand side plates are directly connected to the negative terminal, and the negative end is connected to the right hand side of the plates, and hence all the right hand side will be getting negative charges, right? All the left hand side of the plates of the capacitors are charged to positive. Why? Because they are directly connected to the terminal positive, and the negative terminal is directly connected to the right hand side of plates of the capacitor, and hence they have the capacitance C1, C2 and C3, right? Now here, as the total amount of the charge coming out from this particular source is positive Q, and hence this positive Q is being divided into 3 different parts of the capacitor, and hence the capacitance stores different amount of the charges into it, right? Now here what happens, you have same potential but different amount of the storage charges, right? Why same potential? Every particular point or every capacitor is connected to the same amount of the positive and the negative terminal, and hence potential will be same whenever you connect the capacitors in the parallel combination, right? Now what you do is, if at all you want to say for example, if at all you want to convert this into the equivalent diagram or equivalent capacitor, then you write it as positive, negative, parallel, positive and negative, right? Now what is the charge storage? I said you the storage of the charges is different for all the 3 capacitors, but the potential remains same. Why? Because they are connected to the similar terminals, right? Now what is the charge stored? What is the total charge stored in the capacitance, equivalent capacitance? It can be given as C into V, right? That is Cp, right? Now what is the charge? Now we will find out. However, we know that potential remains same, so we are not finding out V. What is changing? Which parameter is changing? Parameter that is changed is charge. So we found out what is the charge in capacitor C1, what is the charge in capacitor C2, and what is the charge in the capacitor C3. And we will find out what is the net charge, that is the total effective charge on the capacitance, right? Now, the charge in the C1 will be Q1 is equal to C1V, right? Now this is the charge on the C1 plate. What is Q2? It is C2V, right? What is charge on Q3? C3V, right? Why are we writing only V here? Why not V1, V2 and V3? Why? Because the potential remains same. You need not write. There is no point in writing the notations here, right? The potential is same for all the capacitor, and hence you take it as the same thing. If at all the total amount of the charges I needed, then how it is written? It is written as Q is equal to Q1 plus Q2 plus Q3, right? And hence the connection are in series, so the effective charge will be QP, right? Now by this equation, that is this and this equation, you can clearly write that C1V plus C2V plus C3V, right? The potential remains same, so this get cancelled, right? The effective capacitance of the capacitors when connected in parallel can be written as C1 plus C2 plus C3. This is the effective capacitance of the capacitor when they are connected in parallel combination, right? Now say for example, in the series combination, the effective capacitance was decreased when the capacitors are connected in the series combination, right? Now in this parallel combination, whenever you connect the capacitors in parallel manner, right, what happens? The effective capacitance increase more than the highest value of the capacitor, right? There in series combination, it was decreased to the lowest value of the capacitor, decreased than the lowest value of the capacitor. Here in the parallel combination, the value of the capacitance increase more than the highest valued capacitor in the circuit. Say for example, you have a circuit. This is first capacitor, second capacitor, third capacitor, right? They are connected in parallel, right? First was 1 microfarad, 2 microfarad, 3 microfarad, right? This is the combination, right? If at all you want to find out what is the effective or the equivalent capacitance which can give you the same value to that of all the capacitors connected, why we use equivalent or the effective capacitance? We do not wanted the different types of the capacitors to be connected in the circuit. Instead of like connecting the three circuits, or instead of connecting the three capacitors in the parallel, if at all one capacitor gives the same effect of all the three combination, then using one capacitor is more desirable than putting the three capacitors in the circuit, right? And hence because of this, we always find the effective capacitance, and that capacitance is used in the electrical circuits, right? So what will be the total capacitance for this? That is Cp is equal to C1 plus C2 plus C3. That is 1 plus 2 plus 3. How much it is? 6 microfarad. Now you tell me the effective capacitance when the capacitors are connected parallel has increased. It is increased definitely, right? It was initially, it is increased to what value? It is increased more than that of the highest value capacitor in the circuit. In this circuit, what is the highest value capacitor? 3 microfarad is the highest value capacitor, right? What is the total capacitance or the effective capacitance you have got? It is 6 microfarad. Now this 6 microfarad is greater than 3 microfarad, right? And hence, whenever you wanted a capacitance value to be increased in the circuit, you always connect the capacitors parallelly. Why? Because their effective capacitance is larger than that of the highest value capacitor into the circuit, right? Now this was all about the series and parallel connection of the capacitors. Now you just recall all the things that was explained in this class. We have two combination. First of all, capacitor is an energy storage device, right? Now these capacitors can be used in electrical circuit whenever we wanted an instant discharge, or whenever we wanted instant energy, right? If at all the circuit needs energy very slowly, then we go for batteries or the cell. If at all the circuit need energy very instantly and quickly, then we go for the capacitor. Why? Because they act very instantly and discharge all the energy one at a time, right? And after seeing the explanation about the capacitor, when you know the capacitor, now these capacitor can be connected in two different combination. One, it can be connected in the series combination, and the other can be connected in the parallel combination, right? When you connect the capacitors in the series, you have seen that the charge remains same throughout the capacitors, right? Why? Because there is only one particular point we give a charge, that is the left plate of the capacitor 1, and hence all the other charges are induced in nature, right? And all the charges quantity or of the charges remain same. And what was the different value? We have got the potential varies from one capacitor to other capacitance, right? Now when we have taken effective capacitance of the capacitor connected in series, when we calculate the effective capacitance, the overall capacitance of the circuit decreases. To what amount it decreases? It decreases to a value where you have a minimum capacitor less than the minimum valued capacitor, the effective capacitance decreases, right? Now whenever you want an electrical circuit, or whenever you have an application wherein if you want to reduce the capacitance value, then this series kind of the combination can be used for your application, right? In the parallel combination, what happened? In parallel combination, what is the main difference? There in series, the charge remained constant, potential was different, right? Here what happened? Potential remained constant. Why? Because the terminals of all the capacitors are directly connected to the positive and negative. The potential of C1, C2, C3 all are same, and the charge value is different, right? And here in this particular parallel circuit, whenever you wanted to know what is the effective capacitance for the parallel connected capacitors, the final capacitance will be always greater than that of the highest value capacitor, right? Now whenever an electrical circuit or the application where you wanted the capacitance to be increased, or you wanted a higher capacitance, then you always connect the capacitors in parallel combination, right? This was all about the capacitor and how the arrangement is done, right? And this was all about today's class. I hope you people have followed it very clearly, right? You please do share my link to all your friends and families. Do subscribe to my channel, and the material for this particular explanation is given into the description box. You can go through, download my notes, and then you can study it very easily. Please do keep visiting my channel and do watch all my videos, and thank you so much.